Hi, this is question 2 of level 2 for trigonometry. And ABC is a right-angled triangle in which AB is 12 cm. So I'm just going to label that quickly. AB 12 cm. And BC is 13 cm. So this is 13. AC is produced to P. And when it says it's produced to P, what it means is that AC is produced to P. So ACP is a straight line. I mean, this is 180 degrees. AB is produced to Q, that means this is a straight line, and this is 180 degrees. Given that CP equals to BQ, so let's write that down. CP and BQ are the same. So maybe let me color code it by doing it this way. CP, right, is the same length as BQ. Okay, and area of APQ, so this triangle here, is twice the area of ACB. So to help me visualize better, for APQ, I'm just gonna kind of link it up this way. Right, this is APQ. So that's the triangle. Okay, right now they want me to. So they say that APQ is twice the area of ACB. Find the length of PQ. So this is what I'm trying to find. PQ. Okay, so let's look. The first thing we note is that the only real information they give us besides 12 and 13 and that this is 90 degrees is that the area of APQ is twice the area of ACB. So if I can try to find the area of ACB, which I think is possible, and then I multiply it by 2, I can find this area, and we can see what information we can get from here. So let's just first look at ACB. We can actually find this using Pythagoras theorem. So we can say AC square, that's part A, plus 12 square equals to 13 square. And then we get that AC square equals to 25. And AC therefore is 5. And so this is 5 cm. Alright, and now we can find the area. So we can say area of triangle ABC is therefore, so since this is 90 degrees, then this must be my height, right? So I can simply say it's half times base times height. And if I key all of that into a calculator, I'll just get 30. Cool. And then now I can say that the area of APQ is twice of that. So I can say area of triangle APQ is simply 30 multiplied by 2, which is 60. And how does that help me? It helps me because if I'm trying to find this length, what I might need to do then is apply Pythagoras theorem, and I need to find this. To apply Pythagoras theorem to this triangle, I need to find this yellow part. So what I can do is, let me just call it x, since they are the same. So I'm going to say the area of APQ is 60, right? So I'm going to say half. I'm going to say area of triangle APQ is actually half times, what is my base? 12 plus x. So maybe let me write it this way. Half times 12 plus x base times height, and my height is 5 plus x. And that gives me 60, right? Because we know it's 60. Then if you can solve this, we can find x. So we multiply both sides by 2. Then we get this equals 120. And then we have to expand. So here really is algebra. So 12 times 5. And then plus 12 times x plus 5 times x. This is not the focus of this video, so I'll just go through the algebra and you can check. Cool. And then we solve this now. And the way I like to solve it is simply we just go straight to our handy formula. So we can say So in this case, we're going to say x is therefore equals to minus b plus minus square root b squared minus 4ac over 2a. And so this will give me x equals to negative 20 or x equals to 3. And if x is negative 20, that doesn't make sense because x is a length, so we just have to reject that length is not negative. So x is 3. So over here that is very helpful because this is 3. This is 3. Then now we can apply our Pythagoras theorem, and we can say that this whole length square plus this whole length square equals to this whole length QP square. And so we can say now that 12 plus 5, this is, if you agree with me, this is therefore 15, and this is therefore 8. So we can say 15 square plus 8 square equals to QP square. And you can see that QP square is therefore 289, and QP is therefore plus minus 17, but we reject the negative one, so we just say QP is 17, and we can just scratch this out. Yeah, we reject the negative because it's QP cannot be negative, it's a length. Cool. Part B now. Expressed as a fraction, the value of sine APQ. Okay, and so APQ, that is going to be this angle. And so for this angle, this is my hypotenuse, and this is my opposite, and this is my adjacent. And so feel free to rotate your phone or even your computer a little bit just to take note of and make sure you're able to create this opposite adjacent hypo yourself every single time. And so sine of this angle is therefore opposite over hypotenuse, and so it's going to be 15 over QP, which we found this is actually 17. So for part B, I can say sine of APQ is therefore my opposite, which is 15, over hypotenuse, which is 17. That's it. And now tangent PCB. So PCB is this angle over here, tangent of this angle. And so it's kind of hard to find tangent of that angle, but can we find the tangent of this angle? We can. Yeah, we can say that tangent of that angle, which is BCA, right, is simply opposite over adjacent, which is 12 over 5, right? Because for this angle, for this triangle over here, this is my opposite, and this is my adjacent. Yep. And so 12 over 5, and then we know that tangent of the PCB therefore has to be the negative of that. Yeah, because once again, it's a recap. We know that tangent theta equals to negative tangent of 180 minus theta. So this is a result that we are using to get this.